Now we will discuss about change of order of integration. As we discussed in the earlier two integral, if the integral double integral is defined over a rectangle, say a b c d, that means limit of x are a and b, limits of y are c and d. In this case, I told that integration a to b, integration c to d, f of xy dy dx will be equal to integration over c to d integration a to b f of xy dx and dy. That means we can change the order of integration by changing the integral with limits. Then there will be no harm at all. But if the double integral defined over a region, say E is my region, which is nothing but AB. Now phi of x is less than or equal to y, less than or equal to psi of x. And that integral we have to write in this form since y is having the limits as a function of x. So the outer integral will be with respect to x, inner integral will be with respect to y. So outer integral with respect to x means the limit of x are a to b, and limits of y are y equal to pi x to y equal to psi x, and f of xy dy and then dx. But here we cannot randomly let that this will be equal to y equal to phi of x to psi y equal to psi of x, and then we cannot write a to b f of xy dx and dy. We cannot write this. Okay, so this is not the correct thing to write. So whenever we will find the question that change the order of integration, first of all we will draw the graph, and from the graph the outer integral we will put the constant limit, and the inner integral, if it is with inner integral is with respect to x, then the limits of y will be function of x. If the inner integral is with respect to x, the limit of x will be function of y. So that can be done by plotting the graph. So let me take an example. Question you will get like this. Example, change the order of integration, change the order of integration, change the order of integration 0 to a, integration 0 to integration y to a x by root over of x square plus y square dx dy, and then evaluate it. That means first we will change the order of integration. If you find that here y is inner integral, x is outer integral, first you have to make it x as inner integral and y as outer integral, and whatever resultant integral you will get, that you have to evaluate. Okay, so now how can we find the limits, which one is inner integral, which one is outer integral? That first we will know, and then we will go for the integration. So here you see First you see the inner integral. Inner integral, one limit is y, one limit is y, and another limit is a constant. So if any one of them or both of them are functions of y, then definitely I will write the inner integral is with respect to x, because it is like this: phi of y is less than or equal to x is less than or equal to psi of y. So but psi of y is constant, it is not a problem. So one of the thing is function of y, so definitely the inner integral will be with respect to x. So now the original integration is of this form: integration 0 to a, and then integration y to a x divided by x square plus y square root over dx, because one of the limit is the function of y. So x will be inner integral and then y will be outer integral. So this is the original or given problem. Now, what we want to make is we want to change the order. Change the order means we have to, here inner was x, outer was y. So we have to make y inner and x outer. That means we don't know what are the limits. We want to make x by x square plus y square root over, and I want to make y is inner and x is outer. X is outer. Now my aim is to find the, if x is outer, what will be the limit of x, and those limits must be constant. And if y is the limit, y is the inner integral, then what are the limits of y, which must be either function of x or constant. Okay, so in order to get this, let us draw the graph of the given thing. So here you see limit of x, limit of y, limit of y are constant initially, y equal to 0 to y equal to a. Limit of x are functions of y x equal to y and y equal to a. So we will write them as like this. We'll write them. So y equal to 0, y equal to a, and y equal to x, or x equal to y, you can say x equal to y and then x equal to a. So let us plot this graph taking all the information. So what I will do here is I will do like this is my x-axis and this is my y-axis. Okay, y equal to 0 means x-axis, y equal to 0 means x-axis. So this is my y equal to 0. Y equal to a, y equal to a means, say I will have some point. So say y equal to a, oh sorry, this is x equal to a. So I can take this is not the thing. I will take y equal to a means like this: x, and this is my y. So this line x-axis is y equal to 0, and this line y equal to a, y equal to a. Then y, x equal to y, x equal to y is the line x equal to y equal to, or x equal to y. Then x equal to a, x equal to a will be this line. So this is your x equal to a. So this is the point 0 comma 0. Now which region we want to find the area, which is the required region. So required region must be bounded by y equal to 0, y equal to a, and x equal to y, x equal to a. So you see that y equal to 0 is this line, y equal to 0 is this line, and x equal to a is this line, y equal to x is this line. Y equal to x is this line, and y equal to 0 is this line. So if I consider this region, I am missing x equal to a. So this is my required region. This is my required region. This region I will not consider, because if I consider this region, I will miss any one of them, x equal to a or y equal to 0. And this line is not prescribed. This line is x equal to 0, but x equal to 0 is nowhere available. So this is my region. In this region, I have to evaluate this double integral, and I have to change the order. So initially, what is the thing given? Initially, we have x is from, sorry, y is from 0 to a. That means y is from 0 to a. What is the coordinate of this point? So it is y, the line y equal to x. So this point will have coordinate a comma a. Okay, because it is x equal to a, and this is 0 comma 0. Now initially I have the limit of y from y equal to 0 to y equal to a, and x equal to y from left to right. Okay, x equal to y to x equal to a. But now what we will do, we will change like this. So initially I had the limit like this. This is the limit of y. Y is from, start from y equal to 0 goes up to y equal to a. Y equal to a is the maximum value of y, and x was like this, left to right. So starts from y equal to x, which is lower limit. Left side means lower limit, y x equal to y, and right side is x equal to a. Now we have to change the order. That means x is outside, y is inside. So x should have constant limit. So what will be the limit of x? Limit of x means from left to right. So this is my left side limit of x. X is minimum 0, and this is my right sided limit of x, that x equal to a. So here I can put x is from 0 to a. X is from 0 to a. Then y limit I will put. Y means bottom to top. So bottom means what is the value of y at the bottom? That is nothing but 0. That is nothing but 0. And what is the top value of y? That should be function of x. And function of x means what is the equation of this line? That is y equal to x. So but y should be function of x. So I will write here x. Now I will evaluate this double integral. I will evaluate this in double integral instead of the given integral. So after changing the order, I will get this integral, and this integral I am going to evaluate. So let us evaluate this. Let us evaluate this integration 0 to a. Already I have said how to evaluate it. 0 to x divided by x square plus y square, x square plus y square root over, and then dy, then dx. Now first you integrate with respect to y, and then integrate with respect to x. So what is the integration of this one with respect to y is, the integration of this one with respect to y is nothing but integration 0 to a, x will be outside, and integration of that one will be nothing but log of y plus root over of x square plus y square. And now I will put the limit from 0 to x, and whatever answer I will get, again I will integrate it with respect to x, with respect to x. So now this will give you integration 0 to a x, and if I put the upper limit and lower limit, what I will get? Upper limit means y equal to x. So I will have log of x plus x square plus x square, 2x square. So root 2 into x is the upper limit, minus lower limit y equal to 0. Y equal to 0 means log, this is 0, this is 0, so root over of x square is x. So this is my upper and lower limit, and I will integrate it with respect to x. So before integration, I will write another line 0 to a x into log of, here x is common, I can say x into 1 plus root 2 divided by x. Log a minus log b is log a by b. So dx. X will get cancelled, so it will be a constant. So we can put it log of 1 plus root 2 integration 0 to a x dx. And finally what we will get? We'll get it as like this, log of 1 plus root 2 and x square by a, x square by 2, and the limit is 0 to a. So finally your answer will be a square by 2 log of 1 plus root 2. So this is the way we can change the order and evaluate the integration. Now we can go for another example, then we can discuss the thing. So another example is change the order of integration, change the order of integration and evaluate. So what is the original integration? The original integration is integration 0 to a, integration 0 to b by a, root over of a square minus x square in x square dx dy. Okay, so this is the problem. Now you see that the original, in the question, what is the inner integral, what is the outer integral, first you identify. So integration 0 to a, then integration 0 to b by a, root over of a square minus x square. Now you see that in the inner integral, one of the limit is function of x. So definitely the inner integral will be with respect to y. Okay, and our outer integral will be with respect to x. This is of the form phi of x is less than or equal to y is less than or equal to psi of x. So phi of x is although 0, but psi of x is function of x. So the inner integral will be with respect to y. So this is the given problem. But what we need to do is we want to write this one in the form integration x square dx. We will make x inside and y outside. Okay, but we cannot write simply as like this. We have to plot the graph. From the graph, we have to write the limits of x and y such that the limit of y will be constant and the limits of x will be functions of y, either constant or functions of y. So now how can we plot the graph? You see that here outer integral is with respect to x. So the outer integral, whatever limit it has, that will be limits for x. That means x equal to 0 and x equal to a. Now inner integral is with respect to y, so the limit of inner integrals are the values of y. So what will be the values? Lower value is 0 and upper value is nothing but y equal to b by a root over of a square minus x square. Okay, so these three things we don't have any problem, this one, this one, this one, but this we have to simplify. How can we simplify it? So let me take here ay by b is equal to root over of a square minus x square. Now I will take square on both sides, which will be nothing but a square minus x square. Okay, so this is equivalent to saying a square y square by b square is equal to a square minus x square. Now divide throughout by a square. So we will get a square by b square. A square by a square is 1 minus x square by a square. And so this is equivalent to x square by a square plus y square by b square is equal to 1. And this is nothing but the ellipse. This is nothing but the ellipse. So let us draw the thing. So what are the things we need to consider? X equal to 0, x equal to a, y equal to 0, and another ellipse. So what I will do here, this is my x, this is my y axis, this is my x axis. So this is my y, this is my y, okay. And so this is origin. So what I will do, x square plus y square, x square by a square plus y square by b square. That means the coordinate will be like this. Focus will be like this. So here it will be minus a, here it will be plus a, here it will be b, here it will be minus b. So that means here minus a comma 0, here I will have 0 comma minus b, here I have a comma 0, here I have 0 comma b, these points. Okay, so this is the thing, but you see that we are taking only positive root over. So positive root over means we are considering about the first quadrant, we are considering about the first quadrant. Positive value, oh sorry, this both the thing we will consider, since it is starting from 0, so we will consider from the first, consider the first quadrant. So now you see in the first quadrant, limit of x is from 0 to a, limit of y means from bottom to top, bottom is y equal to 0, top is the curve, and that is the thing here all initially given. But now we want to change the order, we want to change the order. That means we will put x inside, y outside. If we put x inside, y outside means y should have the constant limit. So what is the minimum value of y on this line? 0. So I can put the limit of y as 0, limit of y as 0, lower limit. And what is the upper limit? Upper limit means maximum value of y is b. So I can put here b. I can put here b. Now I will see the limit for x. Limit for x means left to right. So left side the x value is nothing but y axis, and at y axis x equal to 0. So I can write the lower limit of x equal to 0. And what will be the right hand side? So this will be the limit of x. This will be the limit of y. Y is from 0 to b, x is from 0 to this curve. This curve means we have to write x in terms of y. Originally it was given y in terms of x. Now we will write x in terms of y. So x square by a square equal to 1 minus y square by b square. And so b square minus y square by b square. And x square will be nothing but a square by b square into b square minus y square. So what will be my x? X equal to plus or minus a by b root over of b square minus y square. But out of these two values, we will consider only positive value because it is in the first quadrant. And so we can write the positive limit as here a by b root over of b square minus y square. Now we will evaluate it. Now we will evaluate this thing. After writing the limit, we will evaluate this. So what is the new integral now? My new integral is integration 0 to b integration 0 to a by b root over of b square minus y square x square dx. Since inner integral has limit function of y, so it will be x and then y. Now we will evaluate this. Now we will evaluate this. So let me integrate it with respect to x. We will integrate it with respect to x. So what we will get here, integration 0 to b integration of x square will be x cube by 3 and the limits are 0 to a by b root over of b square minus y square, and then whatever value I will get, I will integrate with respect to y. So 1 by 3 is constant, I can take it out to 0 to b, and then I will write here a by b root over of b square minus y square whole cube dy. Lower limit is 0, no need to write the lower limit. And so what will be the thing here, a by b cube means here we can have a cube by 3b cube integration 0 to b root over of b square minus y square, or you can say this one as, you can say b square minus y square to the power 3 by 2 dy, to the power 3 by 2 dy, and you can integrate it by putting, by substituting. So what is the substitution you can do? Let y equal to b sine theta, y equal to b sine theta, then dy will be b cos theta d theta, by will be b cos theta d theta. Now whenever y equal to 0, whenever y equal to 0, what will be theta? Theta will be nothing but 0. Whenever y equal to b, theta will be nothing but pi by 2. Theta will be nothing but pi by 2. So the original equation can be written now. This equation, that consequence equation, can be written as a cube divided by 3b cube integration. Instead of limit of y, we will put the limit of theta. Theta is 0 to pi by 2, pi by 2, and this will be b square minus y is b sine theta, so b square sine square theta to the power 3 by 2 into dy means what we will put, b into cos theta d theta, b into cos theta d theta, and so a cube divided by 3b cube. Here you see integration 0 to pi by 2. Here b square common you can take, so b square to the power 3 by 2 is equal to b cube. Already another b is here, so we can have b to the power 4 into 1 minus sine square theta to the power 3 by 2 cos theta d theta, cos theta d theta. So a cube b4 divided by 3b cube integration 0 to pi by 2. Here 1 minus cos square, 1 minus sine square theta, 1 minus sine square theta is cos square theta, so 1 minus sine square theta to the power 3 by 2 is equal to cos square theta to the power 3 by 2. So 2 will get cancelled, cos to the power 3. Cos to the power 3. And so we can have cos q theta into cos theta d theta. Okay. So finally what you will get? AQB divided by 3 integration 0 to pi by 2 cos 4 theta d theta. Okay, so this is equivalent to your beta function. Beta of mn, beta of mn is integration 0 to pi by 2 cos m theta sin n theta d theta. So that formula we can apply here. That formula we can apply here. So here sin n means n equal to 0. N equal to 0. So we can write here it like this. This is the thing equivalent to saying. This is the thing equivalent to saying integration 0 to integration 0 to pi by 2 integration 0 to pi by 2 cos px sin qx dx equal to beta of p plus 1 by 2 q plus 1 by 2 1 by 2. Okay, so this will be the thing. So now we will apply that one and we will try to simplify it. What we will get is n equal to 0, p q equal to 0, p plus 1 by 2, and here q equal to 0, q equal to 0, and p equal to 4, p equal to 4. So what we will get here, this is equal to AQB by 3 into 1 by 2 beta into 4 plus 1 by 2 0 plus 1 by 2, and that is equal to AQB by 3 or 6, you can say 6 into beta of 5 by 2 1 by 2. Okay, but this is equivalent to AQB by 6. This is equal to gamma of 5 by 2 gamma of 1 by 2 divided by gamma of 5 by 2 plus 1 by 2, and that will equal to AQB by 6, and this one will be gamma half is root pi, and this one will be 3 by 2 into 1 by 2 into gamma half divided by gamma of 6 by 2 is gamma of 3, gamma of 3. And so what we will get here, further simplifying it, we will get AQB by 6, and this one is root pi into root pi is pi, and this one will be 3 by 4 divided gamma 3 equal to 2 factorial. Okay, and so that will give you AQB divided by 6 into 3 by 8, and finally you will get AQB by 16. This will be your answer. This will be your answer. Sometimes what will happen in the given integral, it will represent a single region, but in when we will change the order, we have to divide it into two region. We have to divide it into two region. I will consider one of such problem. Example, change the order of integration and then evaluate. Change the order of integration and then evaluate. And then evaluate. So what is the given integration? 0 to 1 integration y to 2 minus y xy dx dy. Now you can easily tell me what is the inner in the original question, what is the inner integral, what is the outer integral. So here we can see that the inner integral has a limit as a function of y. So definitely the integral will be with respect to x and outer integral will be with respect to y. So I can write it as 0 to 1 and integration y to 2 minus y xy dx, and then outer integral will be y. So this is the given one. This is the given one. Now what we want to write is, we want to write this one as like this: integration xy, in place of dx I will put y, in place of dy I will put x. I want to write this like this, and I have to find the corresponding limit. For that I will sketch a graph by taking the original limits. So in the original form, what are the limits of y? Y is 0 and 1. What are the limits of x? X equal to y and x equal to 2 minus y. So let me write here y equal to 0, y equal to 1, and x equal to y from the second integral, x equal to y, and then x equal to 2 minus y. So 2 minus y is equivalent to x plus y equal to 2. Now I will draw this graph. How can we draw it? So this is my y-axis, this is my x-axis, this is my y-axis. So y equal to 0, y equal to 0 is x-axis, y equal to 1 is the line parallel to x-axis, so y equal to 1. Then x equal to y, x equal to y will be this line, okay, and x equal to 2, say this is my x equal to 2, x equal to 2. So this is my x equal to 0. This point is 0 comma 0, and this point is 2 comma 0, and this point is 0 comma 1. Now I want to find the value of this point. What is the value of this? This is y equal to x. X equal to how much? Y, no, this is nothing but, so this value will be nothing but, yeah, I have missed another line. The line will be like this: x plus y equal to 2 is also there. So that line we have to sketch. X plus y equal to 2 means that line will be like this. It will come like this. Okay. So that I will see how x plus y equal to 2. Here 2 I have not. Okay. So please ignore this graph. So what I will do, here I will sketch another one. This is my x-axis and this is my y-axis. Y equal to 0 is this, y equal to 1 is this, y equal to 1. Then x equal to y, x equal to y will be this, x equal to y will be this, y equal to x, and x plus y equal to 2 will be the line like this. How can we get the line? This is x plus y equal to 2. If I put x equal to 0, y equal to 2, that means somewhere here I will have 0 comma 2, so that it will be intersecting there here. Okay, and when I will take y equal to 0, x will be nothing but 2, so that will be here somewhere here. So initially you see this point, this point at least we know that y equal to x, and so it will be y is 1, so x is 1. Okay, this point is nothing but 2 comma 0. This point is nothing but 0 comma 0. Now in the original question I have the limits of y. I have the limits of y from 0 to 1. From 0 to 1, yeah, the limit of y, here you see, this is limit, lower limit of y, and this is upper limit of y. So the limit of y is from 0 to 1, and the limit of x left side is y equal to x. So you see left side is y equal to x, and right side is x equal to 2 minus 1. So initially it was there. Now we have to change the limit. We have to change the limit. That means what we will do? We will write x outside, y inside. Okay. Now if I write this one, suppose x limit I will find. So x limit I will find means what will happen? X is from 0 to 2. I can write, there is no problem. I can write it. But when I will change the limit of y, when I will change the limit of y, you see here I will have the one of the upper limit is y equal to x. But here I will have another upper limit of y. So I will have two upper limit of y. So only one integral will not give you the proper change of order. So when I am changing the order, I am getting two upper limit for y, and so I have to write two integral for the single integral. So what I will do here is I will have integration. What are the things we are having? Xy dy one thing, and another is integration xy dy and dx. Okay, so now I will first consider this region. So in this region, this is my x equal to 1, this point is x equal to 1, 1 comma 0. So now x is for this region x equal, starting from 0, x is the outer integral, so it should have constant limit, so 0 to 1, and y is the inner integral, it should be function of, the limit should be function of x, but y limit is 0, we will put 0. Upper limit is the line y equal to x, so I will write here x. So this is one integral, and in the second region we have the limit of x is from 1 to 2, 1 to 2, and the limit of y down lower limit is 0 because it is x-axis, and then upper limit is, in terms of x we have to write y, so 2 minus x. Now we will evaluate these two things, and that will give you the answer. So you can evaluate it, integration 0 to 1, and this one will be with respect to y, it will be, x will be constant, so it will be xy square by 2, and the limits are 0 to x, and then dx, and similarly 1 to 2, and this one will be xy square by 2, limits are 0 to 2 minus x dx. Okay, so now this is equivalent to saying integral 1 by 2 is constant, 0 to 1, and this one will be nothing but x cube dx, plus here also 1 by 2 is common, integration 1 to 2, here what we will get, x into 2 minus x whole square, and dx. So now the integration of this one is x to the power 4, 1 by 2 into x to the power 4 by 4, and the limit is 0 to 1. And here what I will have is 1 by 2, integration 1 to 2, x into 4 minus 4x plus x square dx. So this one will be 1 by 8 plus 1 by 2. Integration of 4x is 2x square. 4x square by 2. So this one is integration of, so you can take another step, 1 to 2, 4x minus 4x square plus x cube dx. Now you can integrate it and put the limit. What you will get, 1 by 8 plus 1 by 2. Integration of this one is 2x square. Integration of this one is minus 4 by 3 x cube. Integration of this one is x to the power 4 by 4. Limit is 1 to 2. Limit is 1 to 2. So if you simplify everything, you will get like this. This is equal to 1 by 8 plus 1 by 2, and upper limit you put 2 square into 8, and this one will be 8 32 by 3, and this one will be 16, 2 to the power 4. 2 to the power 4 is 16. 16 by 4 is 4. Upper limit minus lower limit x is 1. 2 minus 4 by 3 plus 1 by 4. Okay. So what is the simplification? If you simplify it, you will get 1 by 3. So this is the way to change the order of the integration and evaluate the double integration.